Hi, my name is Anders, and in this video I will give an overview of our ECCV paper, Geometry Fidelity for Spherical Images. Omnidirectional or spherical images have become an interesting format for image generative models for applications like virtual reality, since they capture a full scene in a single coherent image. Spherical images are oftentimes projected between the sphere and 2D representations for purposes like model training, generation, evaluation, and presentation. However, due to the inherent projection distortion, it can be tricky to evaluate proportions and geometry in the 2D representations. Indeed, this image is not actually a spherical image. Instead, this is the true spherical image. Here we show them again side by side. The second image has been corrupted to artificially reduce vertical field of view, which result in objects converging to the poles of the sphere, shown below. This issue is also found in state-of-the-art models, despite achieving low FID scores. We observe semantic and lighting discontinuities, as well as the field of view issue we demonstrated before. We want to stress that this is likely not due to the model. Indeed, the authors behind the generations thoughtfully incorporate the spherical geometry into their model. Instead, we find two other reasons for this behavior. The first is low availability of spherical images and usage of ordinary panoramic images, which do not have full field of view. The second reason are the employed metrics. In this work, we focus on the latter issue. Specifically, we demonstrate that FID is not suitable for spherical images. We propose a simple but effective extension of FID to accommodate for spherical structure, along with a simple score for detecting border discontinuities. We hope that this paper can spark further discussion and development. To test the awareness of the spherical geometry of metrics like FID, we propose a transformation that lowers vertical field of view. The corrupted image displayed earlier is an example of this. As suspected, we see that the FID score is oblivious to this. The FID barely increases as we decrease the field of view by 40 degrees. As such, FID is not a reliable indicator of images being spherical or not. Despite issues, FID has established itself as the de facto standard metric for image generative models. We therefore want to minimally change the FID metric and instead wish to adapt the images to the metric. Specifically, we use cube-map projections, which gives us 6 perspective images that are square, includes the spherical poles, and have less projection distortion compared to the equirectangular image. By grouping the 6 perspective images into 3 semantic groups, we can compute the FID score over the groups individually and simply average them to get our proposed Omni-FID score. This very simple change is actually sufficient to detect issues related to vertical field of view, and we confirm that we maintain beneficial properties of FID like its sensitivity to noise. We also perform a small qualitative comparison of FID and Omni-FID on generated images. The second issue relates to the image border discontinuities, where content of image borders do not align. To detect such issues, we propose a simple kernel-based score based on pixel intensity changes. Here we can leverage a priori knowledge of locations of potential discontinuities, avoiding the problem of detection. The score separates well between true spherical images, such as the Laval and Polyhaven datasets, corrupted images where we have added a minor scene, and generated images, which in our case contains discontinuities of mild nature like lighting differences, or severe semantic issues where content across image borders do not match. This is also evident in our qualitative evaluation, where the images with low scores on the left only contain mild seams, where the high scores shown to the right have semantic mismatches, such as 2 different buildings colliding. We will be presenting our poster at the afternoon session on the 1st of October, and we are looking forward to discuss. The QR code at the bottom right will direct you to our paper. Thank you for watching.